Welcome back to Thailand. It's the end of a beautiful winter's day. Sun is setting in the west, and that means I'm busy working on my project. And this takes us to the next installment of Mikey's smart home system with solar power. Now, in the previous video, you saw all the software that it took to be able to record and display all of my solar data, of course using fake data. Now we're going to do the real thing. We're going to put a solar module out on my balcony and make some power off it. So this is one of my highly beautiful and scientific diagrams. This is the module which will go out there on the balcony. The DC connectors that come off will go into the microinverter. The AC output of the microinverter is going to come into a weatherproof box that acts as a junction box for wiring, and it also provides a circuit breaker with a disconnect feature built into it. And that's really important because you always need to protect your wire. The purpose of a circuit breaker, most people don't know, is not to protect your device. It's to protect the wire from overheating and catching fire and burning your house down. That's all the National Electrical Code cares about for fuses and circuit breakers. But this also provides a manual on-off switch that will isolate any power coming from the module to where it gets plugged into my wall, and I'll explain that in a sec. So we have safety and a disconnect feature here. The output of that comes through that sawn-off power meter that I showed all of the software working out of last time, and the AC comes straight through here into a power plug that plugs into the wall. Now, most solar power systems get wired into a circuit breaker panel with real circuit breakers for a number of issues. One, it's generally electrical code in most places in the world, but it also provides the capability to dump a lot of energy and power into your condo or your house's electrical system. In my case, I'm putting 300 watts in, which is a little bit more than my TV or maybe my computer and all my computers and my TV put together. Certainly I'm not making 5,000 watts of power like I did back in my house in California. And a wall outlet can easily handle that amount of power being put into the electrical circuit in my condo. The power will either be consumed by something on the wire here, or it goes back to the breaker panel and will go out to another device. So I'm basically powering all of the AC in my room. I have a spreadsheet of all my electric bills for the last 6 years. I've never, ever made less than 300 or consumed less than 300 watts of power while I'm actually in here and all my computers are turned on and stuff, and generally vastly more with air conditioning and things. So that will definitely prevent my electric meter from spinning backwards, because that's a no-no. So we have safety, we have disconnect, we're turning DC into AC and putting it into the wall. This is for my prototype. When and if I decide on my long-term strategy with my mounting system on the balcony and how I want to do this, I will run this into a real circuit breaker in my panel, but that involves drilling through masonry walls and going 3/4 of the way through my condo to get back to the breaker panel. So I'm not going to do it for this initial prototype. So let's jump in and we'll take a look at the module and this box and the microinverter, and then decide how we're going to actually install the system. And the next phase of my cunning plan is coming to fruition. This is my new solar module. Now, if it looks bigger than you were expecting, you'd be right. That is I think, a queen-size bed, and it covers almost the whole thing. My original plan was to get a 175 watt module and a microinverter that could drive it. It's just enough to make some electricity and, and do a science experiment. But then I found all the microinverters that I had access to needed a higher wattage panel. And the wattage is actually, or the microinverter is driven by the input voltage of the panel. And the 175 was too low, something like 18, and I needed 24, 25 volts. So I went to this solar supplier in my town and ordered a 250 watt panel. Guess what showed up? A 310 watt panel. They said they were sorry because of the delay that it took them to ship from Bangkok, but it's the same physical size as the 250 and the same price for 310 watts. And I appreciate that. I'm guessing they didn't have any 250s in stock and they had this one, so that's what I ended up with. But anyway, we're both happy. Let me flip it over and we'll take a look at the specs. Now, given my proximity to China, and the Chinese modules are generally fine these days. When they first started, they were pretty dodgy, but they're up with anything else in the world. I fully expected a Chinese module, but look what showed up. If you can read the writing, Sun-Free, presented by Sun Ever GmbH, Germany. Now, this is a German company's label on here. It may be manufactured in China, and then they stick their label on it. But, the Germans don't mess around. So if this thing's got a German company behind it, I am more than happy. You see the operating voltage there is 32.6. That's well within the operational range of the microinverter. So we should be good. Okay, here I've got this power monitor and breaker / power isolator switch mounted in an outdoor enclosure. This wire right here goes and just plugs in to an outlet, and the microinverter will come in here, ground here, line and neutral, and when I turn the switch on, the system should come alive. Okay, it's looking for its Wi-Fi. Now I've got the configuration page for the switch set up right here. So when I click on this toggle button, that light there. So it's now active. I'm not going to put anything metallic in there. Active. And this little blue LED has come alive on the breaker, which shows that it is active. I've tested the voltage across there. It's about 230 volts AC as expected. So the microinverter should come in here through the breaker and then into the meter and then out to the wall. And that's enough for our testing purposes before I do a permanent install when I get the system set up the way I want it. And I've just had a delivery from FedEx's partner in Thailand. Box had a very rough journey from China. I'm hoping the microinverter and the power meter box are in here. Now, one thing that happens is anytime anything shipped from overseas through UPS or FedEx, they go to the government and get it classified for import duty. So I paid $11 import duty on this. If packages come through the post office, sails right through, especially for small value things. I mean, if I'm buying $3 worth of connectors from China, it doesn't matter. But paid an extra $11 in import duty for that. So let me pop this open and we'll see. Here's an amusing side note. Often the company name on AliExpress, it doesn't necessarily mean it's the same name of the company it's coming from, but this one came from the Xiamen Mars Rock Science Technology Company, and they're selling solar inverters. Now, maybe they already have a branch office on Mars. I don't know. They beat Elon to it. Okay, here's the relatively straightforward instruction manual. It's 300 watts, and this is my wiring setup, 230 volts single phase. So it's just line, neutral, and ground going straight in, no problem there. It's got all the other wiring scenarios, 2-phase, 3-phase for both 230 volts and 120 volts AC. It's got the daisy chain diagrams if you have more than one microinverter, and it's got a picture, and here it is. So on this side, this is the incoming AC from the previous microinverter, and it's got a very, very unique connector on it that I've never seen before. And the two MC4 connectors that the module will connect to. This is DC coming in here, and then the AC comes out here, and again to the male version of that very unique connector. But I don't have something from here like 3 pigtail wires, and it makes me sad if I'm going to have to cut off this connector just to get to the wires, as if this is the last one in the chain or the only one in the chain. This is the status LED. It blinks with various codes for AC fault, DC fault, internal fault, and frequency issue. And then it's got the smart wireless data connection through this little antenna. And then here's the data box. This is far smaller than what I was expecting. This is the size of a deck of cards. And here's the receiver antenna, and it plugs in to USB, and there's some Windows software that displays your data on a Windows PC. I'm wondering what I need to do to be able to get at the raw data out of this thing. That's an experiment for the future. But I think I'm going to do is ping the seller and see if he's got something that screws on here and goes maybe 10 feet and gives me the 3 necessary wires to connect into my box. Otherwise, I've got to cut that connector. And that means, because this is so short, I need a small junction box, and then I need a longer wire to get to my other box with the power meter and the disconnect/circuit breaker. So let me get on that. Now, the issue we're going to run into when I had to move up from a reasonably sized module to this one is size. Now, if you look at my balcony, it is small. I mean, that is 1, 2, 3, 4, just barely 5 feet that way. 1, 2, 3, 4, 5, almost 6 feet that way, plus a little storage area under the aircon. So I've got to get the module in this space. Now I'm going to try 4 scenarios. The first one is lying flat. And each of these scenarios is going to provide a greater amount of power, but with more visibility to the outside, which is not necessarily a good thing according to the rules of my condo. So first one, we're going to lay flat. Now the sun rises on the left side of my balcony, crosses in front, and then sets on the right side of my balcony, and there you can see the sun just setting over the hills. So I'm going to need to center the module in this space so the sun tracks across. Now there's definitely going to be some shading. You can see it right there. And the railing has a shading effect in itself. So the first one's going to be flat. Then I'm going to be flat on the ground but angle it up at 12.5 degrees, because that is my latitude above the equator, which is the optimal angle to catch the sun going through the sky. Now, being this close to the equator, we have very, very similar length of day between summer and winter, and the angle of the sun in the sky from sun and summer and winter. So one fixed 12.5 degrees coming this way is going to be the next, that's the number 2 try. Number 3 try is I'm going to have the front edge here and then coming up here at a 12.5 degree angle. So it'll be going like this. I'm going to have a little bit of block from the left and the right, but primarily open to the sun. You might be able to see this bird netting. It's translucent and very thin, so it shouldn't be too much of a problem. But I'll tell you, this saves my bacon from the pigeons. You would not believe the pigeons. Option number 4 is just hang it straight vertically off this railing of the balcony, and it'll come down like that. It'll actually overhang the bottom a little bit, but not anywhere near the person who lives below me, if there's someone there most of the time. That will get completely full sun, but it will be blatantly obvious from that little part of the street right there, and that's where the complaints might come from, but hopefully not. But so we're going to try 4 different experiments on 4 different days, and we are in winter in Thailand. This almost cloudless sky through the day, so it should be an equivalent amount of sunshine through the day. So let's get that all hooked up and start the experiments. Okay, this video is starting to get long even by my standards, and if I add in all the module placement experiments, the data collection, the data analysis, it's just going to be too long. So I'll wrap it up here, and then I'll have all the goodies for you in the next video. Welcome, people who stayed to the end of this exciting video. I just want to let you know I've had a bit of an epiphany about YouTube, and it makes me sad. I've been asking people to subscribe to my channel and click the like button in the hopes that YouTube would recognize my channel and kick in a little ad revenue for all these goodies that I'm buying to help me with my little projects. And I realize it's all in vain. YouTube is caring less and less about the people who use its channel. Even the big boys and the big girls are having to go to something like Patreon for financial support, and I'm just not worthy of a Patreon following for anybody. So if you've enjoyed my stuff and you want to see more of it, go ahead and click subscribe and like if you like. Otherwise, just enjoy this picture of my beach here in Thailand and enjoy the rest of your day, and I thank you very much.